Hey everyone, ever stressed over planning a big event? Like trying to figure out how much food you need,
Hmm.
for a huge party, making sure there's enough for everyone.
It's a data problem, and we deal with those every day, even if we don't always realize it.
That's so true. And in this deep dive, we're exploring data through something you might not expect your early math classes.
Yeah. Remember learning about averages or collecting your classmates' heights, maybe even drawing bar graphs?
Oh yeah, definitely. Those were the days.
Well, those weren't just math exercises, they were your first steps into the world of data analysis.
Wow, I never thought of it like that. But it makes sense.
Absolutely. Let's say you're back in school, trying to figure out how many cookies to bring for a class party.
Okay, I'm already feeling nostalgic.
You wouldn't just bake randomly, right? You'd want to make sure there's enough for everyone.
Yeah, maybe even a few extra, just in case.
Right. And that's where data sneaks in. You'd use how many classmates you have, maybe how many cookies each person usually eats.
So I'm already using data without realizing it? You got it. And one of your key tools would be the average.
Ah, the good old average.
You add up all those cookies, divide by the number of classmates, and bam, you've got your average cookies per person.
Seems so simple now.
But, and here's where things get interesting, relying just on averages can be,
Well, risky.
exactly. Imagine you calculate that average perfectly. Cookies baked, you're ready to go. And suddenly, half your classmates show up with surprise guests.
Oh no, cookie chaos.
Exactly. What you thought was enough, based on that average, isn't even close. The data shifted.
Yikes. So what could I have done, besides panicking, of course?
Well, you could have gathered more data, like asking if anyone was bringing someone or had dietary restrictions. More information equals better decisions.
That's a really good point. It's about understanding the why behind the numbers, not just the numbers themselves.
Exactly. And this leads us to some other handy tools, mode and median, which can give us different perspectives on the same information.
Okay, mode and median. Sounds kind of sci-fi, doesn't it? But if they can help me avoid a cookie crisis, I'm all ears.
I promise, they're much less intimidating than they sound. Think back to gym class. Remember when your teacher would line everyone up by height? Shortest to tallest, usually for picking teams.
Yeah, to make it fair.
Exactly.
Yeah.
And to do that, your teacher probably used the median, that middle person in the lineup. That's the median height.
Ah, the median's like the balancing point. Makes sense.
You got it. And our source material actually gives an example. Student heights, 101 centimeters, 102, 106, all the way to 125 centimeters. The median helps us figure out that middle ground. Super useful for fair comparisons.
Okay, that makes sense for median, but what about mode? Anything to do with fashion, by any chance?
You're closer than you think. Imagine you're a clothing store owner.
Okay.
You'd want to stock the most popular sizes, right?
Yeah.
To do that, you look at which sizes sell most often. That's your mode.
So mode is about what shows up the most, like knowing the crowd favorite cookie at a bake sale.
Exactly. It tells us what's trending in the data. And just like those cookies and the chapati example from earlier, mode and median, they can give us a much clearer picture than just the average alone.
This is starting to feel less like math class and more like, I don't know, gaming superpowers or something. But speaking of things we did in school, remember bar graphs? Those seem to help tell a story with data, too.
For sure. Visualizing data is key. Remember how those bars helped us compare things quickly? Like which classroom had the most students?
Yeah, I'm definitely seeing bar graphs in a whole new light now. It's amazing how something so simple visually can pack in so much information. It's like the difference between reading about a sunset and actually seeing a picture of it.
I like that analogy. And just like with those cookies and chapatis, the visuals can help us spot patterns and trends that a single average might miss completely. For example, our source material talks about comparing sunshine hours in two cities, Aberdeen and Margate.
Two very different kinds of places, I'm guessing.
Yeah.
Weather-wise, I mean.
You bet. And putting that data on a bar graph, we instantly see how much more sunshine Margate gets compared to Aberdeen.
It really brings that data to life. But what about when we're dealing with more unknowns, uncertainty? Seems like we need different tools for that.
You're right. And that takes us to our next stop, probability.
Probability. It sounds kind of, I don't know, mysterious, like something you'd hear from a fortune teller. But we're talking data here, right?
Not exactly fortune telling, but probability does help us understand how likely things are to happen. Helps us make sense of uncertainty. Imagine flipping a coin.
Okay, classic coin flip. 50-50 chance it lands on heads or tails.
Exactly. We use probability to put a number on that chance, to quantify the likelihood of that coin landing on heads, for example.
So instead of saying, maybe it'll rain tomorrow, I can use probability to figure out how big that maybe actually is.
Precisely. And we can't see the future, obviously, but it helps us make better decisions based on those likelihoods.
Okay, makes sense. But not everything's as neat and tidy as a coin flip, is it?
You're right. It gets more interesting. Our source material mentions a container. It's got red and white balls in it, but more red ones than white ones. So you reach in, grab a ball at random. Are your chances of grabbing a red ball the same as grabbing a white ball?
Well, if there are more red balls, I'd say there's a higher chance I'd pick a red one, right? Not 50-50 like the coin.
You got it. The probability of picking a red ball is higher simply because there are more of them. It shows how probability isn't always about even odds. It's about understanding the different likelihoods.
So just because the forecast says there's a chance of rain doesn't mean I need to cancel my picnic. I need to look at the probability, the actual likelihood.
Exactly. Understanding it helps us make smarter choices, from those weather forecasts to something like, say, medical test results.
Oh, right. Like if a test is 90% accurate at detecting something.
Right, that sounds really good.
Yeah.
But it doesn't automatically mean a positive result is a guaranteed diagnosis. That 90% accuracy, it's influenced by other things. How common that condition is within the population being tested, for example.
Ah, I see. So even with high accuracy, there are still other things to consider, other factors.
Absolutely. Think back to the container. Just like the number of red balls changes your chances of picking one, the prevalence of a condition in a population affects the meaning of a test result. It's all connected.
Wow, we've covered so much ground today. From our first math classes to the complexities of probability in the real world, it's amazing how it all connects.
It is fascinating how those early concepts we learned can be so powerful. They give us this framework for understanding the world around us.
Totally. So next time you're planning a party, analyzing the news, even just checking the weather forecast, remember what you learned in math class, those early lessons. Might surprise you what insights you find. And on that note, we'll leave you with this. As you go about your day, see if you can spot 5 situations where the outcomes don't have equal chances. It's a fun challenge. Keep those data analyzing muscles working.
Until next time, keep exploring.